In this video, we're starting section 2.4 on sequences and summations. Our goals are to define what a sequence is and be able to find formulas for sequences, solve recurrence relations, be able to use sigma notation, and to compute sums of series. In this video, we'll introduce what is a sequence. So a sequence is an ordered list of some objects. So in part A, the way I read this is anytime I see a comma, that separates out terms of my sequence. So the first term is L, the second term is U, the third term is V, and so on. So the sequence consists of the letters of my first name, Lavreet. And ordered means the order in which I write them matters. So for example, I couldn't switch the L and the V. That would be a different sequence. So in B, I have a sequence of these 4 numbers. In part C, I have a sequence actually of an infinite number of numbers because the ellipses indicates that it goes on forever. So I'm going to let an, or a subscript n, be the nth term in the sequence, where n is some integer. This will indicate, so we can indicate what the starting point of n is. So usually we let n be greater than or equal to 0, or n be greater than or equal to 1. So, for example, in this sequence, if I call the first term a subscript 1, that is equal to 2, then the next term would be a subscript 2, and that value is 3. That's the second term, and so on. So let's do an example where we find a formula for the nth term in sequences B and C from above. In B, I notice that to get from one term to the next, we keep adding 6. So in the formula, I'll put a plus 6n. And maybe instead of starting my subscripts at 1, maybe I'll try starting my subscripts at 0. So I'll say n is greater than or equal to 0. And if I plug that into this, I get 0 currently. But to get the first term, I would need to have a negative 5 in the front here. Okay, and now it kind of checks out and it matches these terms. What would I have to plug into this to get the last term? Well, I would have to plug in 3. So n can go up until 3. Conceptually, I can see that because starting at negative 5, I would have to add 6 1, 2, 3 times, and that's where we ended up ending here. All right. That's not the only way to write a formula for this. For example, if I were to do plus 6n and then use the second term at the front instead and do 1 plus 6n, that also works. We just have to adjust the values for n that we plug in. So to get the first term now, the negative 5, I have to plug in negative 1 for n. And to get the last term, the 13, I would have to plug in 2. So essentially this has made me adjust these values for n all down by 1. That's another totally valid way to write a formula for the sequence. And there's many others. What about for C? So I noticed that this is, the prime numbers. So C is the primes. But there's actually no simple formula for the primes. No simple formula. Sometimes that'll happen with a sequence where there is no nice way to write a formula for it. But often, and in the examples we'll see in our class, we will be able to express it with a formula.